everybody. How are all of you guys doing? I'm fine, just so you know. And today we have a very, very special guest. I have been doing a lot of research about many things, especially, biology, tech, biotech, and all those sort of things for my brother. And I came across him and I'm like, oh my God, I need to connect with this guy. He needs to be on the show, it started as a series of interviews and now it's going on more than 500. So it's like, it's expanded a lot. So let's hear from you, your introduction, and then I think we can kick off this interview.
Salam Rahim. Thank you. And tum kaise ho?
मैं बिल्कुल ठीक हूँ. Where did you learn this though?
मेरी दोस्त in college. So I learned a little. मैं थोड़ा Urdu बोलता हूँ. थोड़ा, okay? So I think we should likely continue in English. It'll be easier for me if we can. But thank you. And मेरा नाम Nathan Pearson. My name is Nathan Pearson. मैं geneticist हूँ. I'm a geneticist. I help people understand DNA, what it tells us about our past as people and as families, but also what it tells us about our present in terms of our health and in some ways our future. So looking at what DNA can tell us about the future for humanity and for families, etc. I think a lot and I work a lot very intently on a specific part of our DNA, of our genomes that we'll talk about. And that choice was driven by a fascination about that part of our DNA, but also by personal story. And I know that you and I share that personal connection in understanding how important DNA can be for helping one person save another person's life. And we'll talk about that. I was very moved to hear from you and to know about the work that you do and how, like your work is finding this focus in who you choose to interview, what you choose to talk about. Likewise, my work as a geneticist has found focus in thinking about how can we help families who really need to get either blood or bone marrow from another family to help a loved one stay alive. That's a mission in the world that's very special and where DNA has a role to play along with our family ties of love and understanding. So I was very happy to hear from you and how aware you were of this, how interested you were, and I really look forward to talking to you, admiring your work as an interviewer.
Thank you so much. It's just like the journey of my brother. He has blood cancer, has had that for about 3 years now. It really moves me, and it was like so many things. For me, it was like, oh my God, this is a new thing to me. Excuse me for a second. So yeah, I was talking about my brother. He has had cancer for, about 3 years, and about this journey, it wasn't just about, for me realizing who I am and how I need to start taking action, but it was also about so many new things that I sort of figured out about this disease. What is it? And I was the first one that my mom and dad told, because they didn't know themselves when they were Googling what is an oncology, sort of word. And they were like, so that's where the doctor's leading us. And there's many people that helped through that journey. And I feel like now that I see my mom and dad helping other people over the phone or over the internet or anything, I feel empowered too, to see that, from how other people can help, even if it's just emotional help. But I can never imagine feeling that helpless, that if you need something that can save your loved one's life and that's not available. Because, even if it's blood, at times, it's very hard to find. I knew a little girl and she was A negative. So her was a negative blood group, and that is very rare. And we couldn't find anybody with it. So we had to practically scout for it. We had to put up ads for it. We had to do so many things because that girl's HP level was very low, was somewhere around 3 point something. So it was very low. So I feel like now that I see my parents helping and I've been through this journey, I know how important it is. Now, the first question that comes to my mind is now I see so many stuff on Instagram and so much stuff on YouTube, and there's always, you know, influencers and explorers. They do different sort of like DNA tests. They're like, you know, you sort of swab the inside of your mouth, or you, I don't know, saliva. People do different things, and then they can know about their ancestry. I never did one, though I've always wanted to do one. But how is that different than this? Now, I read the website, but I'm pretty sure that people that are listening would be interested as to what is the difference and how this is way much more than that.
Okay, so let's talk about what our DNA is and looks like in sort of concrete way, and then focus in on that question. So you can think of your DNA, it's long strings. It comes in long strings that are wound up very tightly in your cells. And there are 23 pairs of those strings. In most of your, in a given cell, typically there are 23 pairs. There are some exceptional cells, but let's talk about the most of your cells. Each of them has 23 pairs of these strings. And they say a lot. They're basically a blueprint for making you. And everything that is distinctive about you, not everything, but a lot of what is distinctive about you, Rahina, as a person, starts there. And so that's sort of a blueprint for what becomes you as the unique person that's like no one else. Even so-called identical twins, even people who share almost exactly the same DNA, they came from the same fertilized egg and they split early and became two people. Even those people have some slight differences in their DNA if you look very carefully in their cells. So everyone is unique. But most of that DNA, of those strings, is very similar from person to person, okay? And I like to think of that, it's almost like, you could think of it like a poem about you. In fact, I think it's a really nice metaphor to think about, say, the famous Urdu form of poetry, which is a ghazal. The ghazals come in pairs, right? The lines are paired. They're like, you know, 15 couplets or something like that. You could think of your genome, your DNA, as like a 23 couplet ghazal that is just about you. And it describes you in exquisite detail. Nonetheless, it is put together and composed by taking one line from one of your mom's ghazal couplets and a paired line from one of your dad's ghazal couplets and putting them together in a beautiful way to make a new poem that is you, okay? And each time they pull together those couplets, sometimes the words can actually link up in new ways before they come to you. So when you look at your poem and you look at your brother's poem, they could match in both ghazal couplet copies at a given stretch, or they could be one line is matching and the other one is different from one parent, or you could have gotten different lines from each of your parents, so they might not match, okay? Now there's one very, very important couplet in the ghazal that is you and the ghazal that is your brother for bone marrow transplant or many other kinds of transplant. And that is the 6th couplet. The 6th lines come in an amazing sort of it's astounding how much diversity there is in those lines among the people in the world. In many ways, it's the most diverse couplet, that 6th couplet, from person to person. So if you're looking for a match there, and there's the genes in that little stretch of those 6th couplet, 6th chromosome, that help our bodies sense, say, a bacterium or a virus. They help our bodies sense what is foreign, what is us. Those genes come in a variety, such variety there that it's important to find a match so that the bone marrow transplant has a good chance of succeeding and providing your brother with new cells in his blood. It's like calling in some new cells to help fight the tumor cells that are growing in him, okay? And calling those new cells in, you want to make sure that they're matched in that 6th couplet so that the cells don't think that that his cells don't think that they're foreign alien cells, and they don't start fighting with each other and making him sicker. So the reason we look for that match is to make sure that when a transplant happens, there's no conflict afterwards between the two, the donor and the recipient cells. They work together in harmony to try to hunt down the tumor cells, which are making him really sick, and try to kill those, and so that the rest of his cells can thrive. That's the goal, okay? And we start by looking for a match in that stretch of the sixth couplet. Now, you already alluded to it, other parts of our genomes that might matter in transplant match for, say, blood transfusion. So our ABO blood type is on a different chromosome, chromosome 9, and the ninth couplet. And it comes in different varieties too, and it's important to match those. And there's another set of genes called rhesus, which are part of the positive negative of your blood type. So matching goes beyond chromosome 6 and this really important stretch of genes called HLA, but to include other parts of our genomes called major blood groups, minor blood groups, etc. So, and in future, this may change. In future, we may try to save the lives of folks like your brother and my mom, who died 40 years ago. We may try to save their lives by actually changing their own cells in very strategic ways that help them fight the cancer better and fight it off. But we're not there yet. So today, anyone on the planet, it's almost a magical thing. You know, people play video games where you save the life of, you know, someone in need. And it feels very good. And game designers are amazing at tapping into this amazing feeling that we have when we can save someone. We can help someone else out who needs us. This is a real life chance to actually save someone's life, and you may not know who they are. They may live across the planet from you. They may live in the same house like you and your brother. You might be a match for your brother, in which case that would be an amazing story. It would really, you know, exemplify the love that so many families feel to try to help each other. But not just as likely, but just as possibly, the person you might be able to save and no one else could save, it might be nobody else on the planet, only you, Rahim, could save this person. They might live in Burkina Faso, or in Sweden, or in Paraguay. They might live across the planet. And so half of transplants that save lives today, half of them cross a border. They might live in India, right? So in some ways, this is a way of people understanding how the ties of humanity and the ties of helping each other can actually transcend borders and politics and the temporariness of that in a much more timeless kind of way. That's the mission that I think differs for a company like Root, an effort like Root, than from other efforts where the main aims are to help you look at your ancestry, and which is a wonderful thing. I love helping people understand their ancestry from DNA. It's a great use. They may offer some very vague today health insights, often not particularly interesting. They may offer some insights about things that you already know about yourself. So I don't know if you like the herb dhania that we call cilantro, right? So I love it, and it sounds like you love it too. I see your smile. Some people hate it. Some people, to them it tastes like soap, believe it or not, okay? And it turns out that there are parts of our genomes that help explain that. So it can be fun to understand what science has learned about, like, why you like dhania and why I like it and why somebody else doesn't like it. But those in some senses are, let's be frank, they're a little bit more trivial kinds of insights and uses than using DNA to find the match that is needed to save the life of your brother. That is a much more urgent use, not just for you as your brother's sister, but for me as a fellow human, and for anybody listening and for anybody that they know. That use can happen today. It's real. It's more real than any video game. Any person can, in principle, be the one lifesaver for somebody else they never met. That's what we want to make happen.
That is so true. Now, there's a common misconception, which I was super scared of when the time, you know, where I was like, is this happening? For like, you know, at some point in time, we did consider, you know, I forgot the word for it, but we did consider
a transplant, the bone marrow transplant?
Yeah, sorry.
Yep.
Thanks for the word. I'm like, is it a transfusion? Is it what? So, yeah, we considered it. There's many people that told us, like as a family, that, oh my God, if your daughter gives, a little bit of that, she's not going to be able to walk again. This is the most common misconception.
Huh.
That I'm not going to be able to walk again, or I will be paralyzed for a while, or is it just for a month, or it's for a year, or I might not be able to live like a normal lifestyle, or that something's going to happen to my children. People have bizarre things. Okay. Now, I pretty much, my doubt clarified when I met one of my very nice friends. Her sister had thalassemia, and they needed to, do a
To
bone
do a
marrow
transfusion.
transplant. So all sisters, there are four sisters, all sisters were tested, but only one was a match. And she did, and I see her running around the park every day. So there's nothing that happened to her, nothing at all. So I think
So,
it's a very big misconception, but please clear that out. An expert is better than me.
well, I think you cleared it up just as a scientist would, because you just pointed to evidence. You observed an outcome of that, and you saw that she's running around and enjoying life, and hopefully her sibling is now too. Now, so, and a lot of people, very few people like needles, right? And so naturally people get worried about any kind of medical procedure like like a bone marrow transplant. So typically there are two ways that they happen now. One is with a needle, and they go into a bone in the lower part of your back, around your hip, and you get typically people get bruising afterwards, and it takes a couple weeks to get back up to full speed. So you would be, out of playing soccer for a couple of weeks, or whatever you love doing in terms of, your running around activities. And nearly everyone, recovers fully within 2 weeks. 95% of people who are asked about that afterward, like, even right afterward or a year later, whenever it might be, if they get asked, would you do this again? 95% of people say, hell yes. Okay? So that should tell you something. Now, there's a second way that's getting more common, which is actually simpler yet. It's apheresis, where it's basically like giving blood for a long time. And the way that works is, instead of going directly into your bone to pull out the cells, they circulate your blood. You're sitting there for a few hours with the blood going in and out of you, circulating, and they're filtering out the cells that are needed for the transplant during those several hours. That's called apheresis. It's a simpler procedure for the person. You stay conscious the whole time, as far as I know. You might be streaming your podcasts or recording an interview. You're always busy. You'd be doing something. And people recover even faster from apheresis. Now, they have trade-offs in terms of how beneficial they are for the patient. So the patient's doctor may sometimes say, we need to be really sure here. So we would really prefer a bone marrow, a hip-based bone marrow donor, where we know that we got enough cells. There might be other cases where they say, actually, we're quite confident that we could work from apheresis cells here. So let's go with that. And we have a willing donor. So the options are increasing. For people who, like any of us, may naturally feel averse to a needle and a little bit worried about, recovering for 2 weeks. But I want to set your and your listeners and your friends' minds at ease that people are in really good hands with modern medicine now. We're in so much luck to be able to save someone's life in some sense so easily, that I'm really glad to hear that you thought about it and said, you would consider doing that, and that you looked around you and saw an example of this happening in the world where everyone is better off quickly afterwards running around together. That's what we want.
Yeah, that's so true. And that's the first thing, that came to my mind, that this should be cleared out, once and for all by an expert. I saw examples. I saw another, child. He was so cute. And he gave the bone marrow to his younger sister. And he was, I think, 5 at the time when I saw him. And he used to run around the hospital because both of the parents were there at the hospital all the time. just run around there. He used to eat a lot, and he was all healthy. Trust me. So I've seen examples. You explained the science. I think we're good to go. Though, when you were talking about blood, I'm like, oh gosh, blood, because I see blood and I start squirming right away. So yeah, even when I saw my own blood for a test, I was like, gosh, please get it away from me. This is gross. Although it's inside my body, but it's gross. So now what I want to know more is how did, of course, I understand from personal experience, and man, this is awesome stuff. You became a geneticist. How was the journey to starting your own company that is now Roots?
So, really important question, I think, for a lot of people today, because so many people have great ideas, and the question is how to make them real. So, going back in time a little bit here, I'm trained as a geneticist, so I learned a lot about what our DNA can tell us. And over years of going to conferences together with other scientists in my field, typically you would go to a big talk where they reveal a new discovery in genetics, and they say, here's what we did in human genetics. We looked at many people's DNA, and we looked across all of those chromosomes, across all the couplets in 100,000 people's ghazals, their poems. And we said, which couplet, where in the poem, helps explain who gets this disease or that disease, or who likes cilantro, or who sneezes when they look at the sun. They could look at any question, and you ask, where in the poem do you find that people's different versions of the poem help explain, they go along with the outcome, okay? And when people do this, they find very interesting findings. So for example, for COVID-19, there's a spot on our third couplet, on our third chromosome, that turns out to be very important for who gets COVID-19 most severely, who is most at risk of catching the virus if they're exposed to it, okay? But often in the picture, you'll get different parts of the poem showing up for the different disease you look at. But time and again, that part of chromosome 6, of the sixth couplet, always shows up. The spellings there seem to be really important in the poem, in what it means for many, many different questions. They're almost like a little prism, like a rainbow prism, where it's one tiny spot that opens light in many directions. And so you would go to a talk, it might be about a viral disease, and there's that spot of chromosome 6, or a bacterial disease in the same spot, or an autoimmune disease like lupus or rheumatoid arthritis, or type 1 diabetes, or ankylosing spondylitis, which is a back disease that strikes when people get into their 30s sometimes. Many, many different diseases. There's a mystery disease of the Silk Road called Behçet's disease, which is a complex one. There's a famous disease called celiac disease, where people can't eat wheat without getting sick. All these different questions, that part of chromosome 6 kept showing up. And when I would go to the talks with the other scientists, typically the presenter, the speaker would say, and of course we saw a peak, we saw that light showing up on chromosome 6 at the HLA region. But let's look at the next slide, because we want to look at a peak we can understand. They kept saying, we can't understand it, it's too diverse. That part of the poem is too complex, too rich with diverse spellings, diverse writing to understand it. And at some point, a light bulb went off, and I thought, well, can we slow down? Can we try to understand why that part of our poem means so much for so many different questions in health and in fun things? And so that question tied together then with another question that I'd known all along from my personal life. And that is that when I was 6, when I was about the age of your brother, my mom got sick with leukemia. She got a blood cancer. And I remember when she took me aside on a summer day to tell me, to explain what was going on, that inside her own, she showed me bruises on her leg. And she said, inside my body, there are cells that are trying to rebel. They're trying to make too many copies of themselves. And it's making my other cells sick, and it makes my body start to have bruises now. And so she explained that she was going to start getting treatments for that and they were going to try to fix it. And it made an impression on me then. And she fought hard. She was sick in a time before bone marrow transplant was really common. Before it had become a worldwide network where you might save somebody across the planet very easily by well-coordinated computer systems and air travel. And by the end, by the time the autumn came, she got very sick. And so I last saw her on our holiday Halloween here, which you may know is usually a fun holiday where kids dress up and go out and get candy from their neighbors. It's a nice thing. And I went to visit her in the hospital, and she was very sick. She couldn't speak anymore. She was in the intensive care unit. She had the nursing staff put out a little cup of candy for me. And so I got, in a sense, to say hello and also goodbye. That was the last time I saw her alive. And that memory, in the few years that I got to spend with her, from the time you spend with your brother, how rich that time can be with a little kid, where, if they're interested in the world and you're helping them explore it. That's how it was with my mom. So she was really nurturing the young scientist in me in ways that lasted. And so when I went on to become a scientist, it's in large part thanks to her and many other people who had done the science and got me hooked on the cool questions that were still open in genetics. And I mean, it takes a village, as they say, and not just one person. But she was a real wonder inspirer for me. And thinking about how many other families like yours, like many strangers who we don't know, they also have a loved one like your brother or like my mom, who, if they stay longer with us and we get to stay longer with them, we can enjoy so much more together. We can have more time to pass off wisdom, to enjoy it, to relish it together, to laugh, and to cry, and to do everything that people do in the circles of loved ones. And I thought, 2 and 2 together, suddenly that insight made sense. That part of our genomes that is so mysterious, that was baffling my colleagues in every talk, it's the same part of the poem that we're reading to find a match for your brother. I didn't know who you were then, but I knew there were people like you, Rahim, and like him, and like my mom, who could benefit from volunteers who had already had their poem read, who were saying, I want to help somebody like your brother. I'm here. If I'm the match, call me so that I can give bone marrow to save that stranger. Those people, millions of them, had already stood up and had their poem read. And they'd never learned anything about it. They'd never gotten anything back for that very good deed, right? They have a poem. They never even got to know what their own poem said on that couplet. That means so much, right? So I thought, well, why don't I start a little effort to make it easier for people to learn what their poem says in that really important part, and to get at least that back from standing up and saying, I will help someone else. They deserve that. And that's very different from, as you alluded to, in the consumer genetics world now, the companies that are out there are largely saying, send us your money, we'll send you back some fun insights about you. That's a different model, though, than saying the millions of people who already volunteered and their data already exists, give them that data back for free. Give them something back that's insight. That was the idea.
I mean, that's amazing. And I was really moved because the time that I had the realization of working very early and to find my true passion was in an intensive care unit. And I remember how much I cried that day. And then, I wanted to do anything that I could to help people around me. And I feel like now that I do have a way, but now I have a question. And, for a while, I did research some biotech, though I'm not the biggest fan. I'm going to admit publicly, I'm not the biggest fan because you talk about blood, I squirm. So that is how I'm not the biggest fan. But now there's always like DNA or genome editing that's going around, and I've heard a lot about it. but it isn't just, I mean, I don't think so. It's as easy that you're like in somebody's guzzle and you just like backspace like some things. You can't just do that.
To rewrite the other.
Yeah, you can't do that. But now how it works, if now I watched a lot of ads and stuff, and there's this ad going around about this. I'm not going to mention any company or anything. It was basically like a thing where somebody got their thing and they're like, oh, I have a cancer causing mutation in my gene or something. But you can't delete that. So that is my point. And if you can, what do you replace it with? You cannot replace it with gibberish.
Oh, this is a great question. You have asked one of the biggest questions that, along with climate, along with the resurgence of maybe nationalisms and populisms in politics, there are some really big questions that are facing humanity in your generation and those to come. Maybe how do we deal with reaching out to connect to any non-earthly life? Those big questions. So you just asked one. We now have technical ways. We have power to change DNA in living cells, including what the method you mentioned, which is called CRISPR, and people will hear a lot about that. How do we use that power wisely, humanely, ethically? How do we make sure that it does the most good and does the least harm? And let's emphasize, people will, like with any technology, people will find ways, or they will try to find ways to do harm. And they may do harm accidentally, like any other technology that has outcomes that may be harmful that we didn't foresee. A good example there might be agriculture. Agriculture was great. Now we have ways of getting more nutrition when we need it, et cetera. But it's led to a lot of changes in societies, including in how we, not just how we eat, in terms of, now we get too much starch and we don't get enough soccer, maybe. And so we end up unhealthy from that. But even in ways that it allows, agriculture allowed certain people in society to get much more resources over time, and other people were left really sort of beholden to those people. And so we think that agriculture increased inequality in societies. That might not be a good thing over time. So likewise, when we think about a technology like CRISPR, we can now change DNA. Wow, what a dream. I mean, so it sounds like a wonderful kind of like Midas touch question, where there are so many things we'd like to try to fix. Let's try to kill off all the mosquitoes. Let's try to fix all the cancer cells right away. Let's try to fix this, fix that. Before we go crazy trying to fix everything, let's acknowledge that we can't always foresee, just as people, we don't have perfect vision of all the chess moves that happen later. We can't always foresee the consequences of changing something. And so let's think about where we might wisely start with CRISPR. Where will it start first? Well, first it'll start outside of people. So we have a lot of other organisms that are close to us in our lives. Crops, livestock, pets, etc., microbes. We will likely start to more widely change the DNA of those organisms before we change many people's DNA. And we'll do so, maybe we'll try to make bacteria that can eat oil slicks, okay? So there's a use that might be good, right? It might have unforeseen consequences, but it might be good. And if we think through that very carefully, that use case, and the possible good and bad outcomes of it very carefully, we can decide what bacteria might we try using, how do we change it, where in its DNA, where in its own little poem do we change it, what do we try to do, and how do we watch and monitor? How do we change the DNA of a plant that we want to grow? Genetically modified organisms have happened for a while, and they're controversial, but they may actually have good uses. Use by use, we need to ask the question. It's not like the technology itself is good or evil. Technology opens possibilities. And so we should think through use by use. Is this likely to help more than harm, and how much? And how efficiently? When it comes to people, we are starting to see uses of CRISPR in people, but there the first important distinction to remember is the distinction between changes in our DNA that we can pass on to a child or another person by a transplant or something like that, versus changes that only stay within us during our lifetime and can help us live longer. And we'll likely see CRISPR start to get used first for the latter. So for example, there's a woman named Victoria Gray. And Victoria Gray was born with a disease called sickle cell disease, which is it's the longest genetically finely understood human disease. And it traces to a little spelling difference in a gene called HBB that makes hemoglobin in our blood. And so she was born with a version of that gene, of that part of her poem, that made it very easy for her cells, which are blood cells that are usually round and can swish through our blood vessels well, to change into this kind of like half moon shape, like a sickle. So, and that sickle shape gets caught very easily as it's trying to flow through, and it creates like a traffic jam. And it can become very painful, very debilitating, and it can kill. So Victoria Gray was born with that disease, which is most common in people from particular parts, whose ancestry is from particular parts of Africa, and also in South Asia. There are parts of South Asia where sickle disease is fairly common. And we think, intriguingly, that having one copy of that version of hemoglobin gene, that it may help fight off malaria. So those people, their ancestors may have been more resistant to malaria, but more prone to this disease. And that's a classic example for us to think about, because there you have a benefit. It resists malaria, but a harm. They often get the traits of debilitating sickle cell trait or sickle cell anemia if they have two copies. So Victoria Gray took a decision, and she was talking with researchers about using CRISPR to change the DNA in some of the cells that make her blood cells, not in her eggs, so that this change would not be passed on to anyone else, but just remain in her tissues that make her blood cells, so that they can make a version of the hemoglobin gene that does not make sickling blood cells and gives her the solidly round cells that help her thrive. And she proudly calls herself, she says, I'm a genetically modified organism. And she's proud of that she's a pioneer in using CRISPR, we hope wisely, to help somebody live and thrive longer, so get more quality time as a person, more time to think free of pain, more time to do what she wants, more time to enjoy it with others. That's potentially a smart kind of first experimental use that could eventually get standardized as we see how to refine it along the way, make it better for people, and use it in different diseases. First in the cells that don't get transmitted. Now let's talk about the long-term, the frontier though. Do we ever use CRISPR to make changes that could be passed on to others? We should assume, I think, looking at how people use technology, people will find a way to use technology any way they can. And so I think this is personally me speaking, I think, and maybe many in our field, that we need to think about how to manage the use of CRISPR for so-called germline use. How do you change DNA that can be passed on in ways that make it most helpful and least crass and harmful? Because we can think of plenty of harmful ways or reckless ways. Now that said, there's always one further twist to it that I want to remind people when we talk about it. If we come to a day that we can change DNA reliably by CRISPR and have it passed on to a child, that likely means that that child, if they have access to good health care, will have access to technology to change it back if they want it. So if we can edit the poem one way reliably, we can hopefully also edit it back. If somebody said later, you know, I disagree strongly with the decision that my parents made, or my parent made, you know, if it's a one-person parent, that could be in the future. And I want to change back to a previous state in my DNA or change to a different one. If CRISPR were reliable as a method, or its descendant methods, that might be possible too, if people have the means and autonomy to do that. So, and I think that's important. Equity, means, autonomy, and knowledge, those are going to be key to go along with the laboratory kind of like Brave New World science of these technologies in future. Hope that you and your cohort can think of it in those broad and complicated terms.
And this is something that came to my mind. First is, of course, if they don't end up liking their ghazal, then they could just change it to a rap song. At this point in time, if that gets that advanced, or like, add a Taylor Swift, song to it, or add like some stuff to it.
Make it a mashup, right? Yeah.
Yeah, and then at the end, it's something that you're like, wow, what is that? Right? So something in between, and something that is, well, it's new, but it has evolved, let's just say, not in the best ways. So anything could happen. Now,
go ahead.
Yeah, so my question was, because I'm taking a summer school, and because I come from ethical and humane technology group, and we were talking about morality and about ethics, especially in biotech. In fact, I wrote an essay about it and made a video about it, and quite some more assignments that were amazing. But my question is, now that we talk about genetically modified people, there's also always talks about genetically modified babies, like designer babies. I mean, like, I'd love for my purse to be Versace, but not like a baby. That is what I personally think, like unconditional love. But what do you think? Is it ethical to genetically modify, not for like diseases, but for personal preferences?
For personal preferences. So, okay, so level setting, this is a toughie, right? First of all, when we edit music online, the stakes are very low. We might end up with a hit. We might end up with, a dud. It doesn't really matter. No one suffers too much other than hearing a bad song, right? That's the worst someone could suffer. When we edit DNA, it's very different, right? The stakes are much higher. And to your point just now in this question, in deciding specifically what DNA spellings a baby will carry, that is a very ethically fraught, weighted kind of task to take on. And it's tempting to think of it as hubris, because we have very little insight now on what a given change will do. And already we've seen the first attempt to do this by a scientist named He. A scientist named He in China decided to change a gene called CCR5 to try to change it to a version that makes the babies in question resistant to HIV. Now, this was unnecessary. They were very unlikely to be exposed to HIV in a way that would put them at risk. Their father, not their mother during pregnancy even, had HIV. So they're very unlikely to be exposed. Moreover, the changes it made turned out to be imprecise. And tinkering with that gene can leave people vulnerable to other viruses, like West Nile virus. So it was not an easy question. This person went ahead and did it as a researcher, outside of the normal ethical protocols that science has in place for this, and not even as a parent. So all of this is to say, Versace, this is not. The designer jeans, this is not. As in jeans as the kind of like pantaloon. These are genes of a different kind. These are genes that leave someone living in a particular way that you can't foresee. And so that's a very heavy responsibility. That said, parents have that responsibility anyway. And when parents choose each other, they're choosing in part, they're not choosing randomly. They're choosing traits in a mate often that in some sense, at least unconsciously, they would like to see more in the world of, maybe via a child. They're choosing traits that attract them and that they think are in some sense great. And so, no one yet has had a child that is an exact copy of themselves or an exact copy of anyone else. Every new child is a new genetic poem that is in some sense reflecting the taste of its composer, right? You are in part, you and two parents are jointly composing that poem together, in interplay, in collaborative interplay. And that's already changing DNA in ways that, you know, again, are in some sense designer. You're trying to make more of the traits that you love spread in the world. But you're doing it in a very imprecise way. And you're doing it in an old way that we understand well, which is, you know, love and romance and sex. That's very different from putting in front of you a blank slate and saying, okay, what do you want to see in a child? Like, you know, a restaurant menu. That's a much more kind of harsh, crass choice to offer someone and to try to offer them. And today it's an irresponsible choice because we can't actually reliably make a child that is all of those dream things that they might write. They might write, okay, you know, taller is great, so I want a child to be 3 meters tall. And I want a child to be the funniest person ever. And I want a child to be the, you know, the best violinist ever. Like, we have no genetic understanding of how to do that. And even if we did, would it be a good idea to make a child 3 meters tall? Would they have, would they be at risk of blood pressure problems? So we need to restrain our impulses there and think, okay, we've done this conventionally in ways that we understand. Let's enjoy that because we know how to enjoy that. And let's think very carefully about where, if anywhere, a slight change to DNA might help a child live longer in a foreseeable way. And I must say, sorry, I'm talking too long, but on the last question, today, is there any urgent use of changing DNA in a baby to a foreseeable thing? I don't see one. There's nothing that we could do in a child today. I would venture to say, I want to put that to nearly nothing, that we could not accomplish more safely by choosing an embryo by screening it genetically. So let's say that there's a couple and they're worried about genetic risk that they share with each other, and they don't want to have a baby that has inherited both copies and is sick. Great use, great question. That question can be most readily addressed and solved by making some embryos and by screening them before implanting. So it's called pre-implantation genetic screening. And they could choose an embryo that does not have 2 copies of that risk. So let's say that they both had sickle cell trait, and they wanted to avoid a child with full-on sickle cell anemia who had 2 copies of HBB that made sickle cells. They could make some embryos together in the old-fashioned way, or actually in new lab ways, and together with an expert physician and geneticist, they could screen those if they had the means and choose a set of embryos to choose from, and then roll the dice and enjoy the wonderful diversity of that child, other than the safety of not having sickle cell disease that they assured. That's a smarter, cheaper, more reliable, safer way to accomplish the same thing than trying to use CRISPR today to flip a switch in that child's in the egg or the sperm. So we may get there where the CRISPR is cheaper and more reliable. I don't know. If we do, okay. But right now we're not there, and so let's be cautiously ethical.
That is true. And I don't know why, like when you were saying about like just like giving like a slate and like write traits down, it's just like I picture something in my head, like, you know, a couple sitting there and being like, should we write funny? Oh no, remember Jenny wrote that and what happened then? You know, it's like you're always like, somebody wrote like romantic and then what happened? And somebody wrote peaceful and then they become drunk or something. So I think it's just going to be like a play of words, which it shouldn't be. It should be a mystery. I mean, I you know, share a lot of things with my mom. I share a lot of things with my dad. I sleep like I am a contortionist, so I sleep in a very different way. That's exactly well how my uncle does as well, and that's how my cousin does as well. So when we do sleep, you know, in one room where we're napping, everybody's like, "Aw, they sleep just like a contortionist." Like, so you know,
like, yeah.
we share stuff, and I think it's beautiful that way. And that is how I'd want to end it. Thank you so much. Do stay back. I've got to talk to you about something before I end the
Yeah.
after I end the recording. Thank you so much for being on. It was a total pleasure having you on. I am going to leave the link for the website for Roots when I put this on, and I'm going to tag you there as well. Thank you so much, everybody, for watching. If you have any questions for me, but if you do have any, like, just like leave in a text on whatever platform you're hearing this, and if you have any to him, I can definitely connect you, or you can do that through the website. Thank you so much for watching, and we'll probably be back because you are something so interesting. Like, you've got so much knowledge up in your head, and I think so, you know, it can lead to many productive sort of conversations and potentially a collaboration. We never know, you know. So thank you so much
Yeah,
for
thank you
watching,
very much.
everybody.